In question 2, we're going to look at creating a linear system to model a specific situation. So if we look at this, the question asks us to create a linear system to model this situation. Again, since it's a linear system, we are going to be using 2 or more equations. In this case, since it's an intro to systems of equations, we're only going to be modeling 2 equations. So the stage at the Lyle Victor Albert Center in Bonnyville, Alberta is rectangular. Its perimeter is 158 feet, and the width of the stage is 31 feet less than the length. So in terms of A, what we're going to do is create 2 equations. Now the first thing we need to do is write a let statement to represent the unknown variables. So the unknowns that we have, since we're talking about perimeter of a rectangular stage and we're talking about the width and the length, these are our unknowns. The actual width in feet and the length in feet. So for my let statement, I'm going to write let L equal the length of the stage. And this is, the units are going to be feet, so I'm just going to put in brackets feet. And I'm going to let W equal the width of the stage. And that measurement will also be in feet, so I'm going to put in brackets feet. Now to write these 2 equations, when you're talking about a word problem situation, typically where you see these numbers and there's a sentence, most of the time each sentence with the numbers in it represents an equation. It isn't always, but in this case it is. So its perimeter is 158 feet. So we can figure out one equation from this. Since the perimeter is 158 feet, when we're talking about a rectangle, 2 lengths plus 2 widths will equal our perimeter, which is 158 feet. So 2L plus 2W equals 158. For the second equation, let's look at this second sentence with this number in it. The width of the stage is 31 feet less than the length. So again, in a previous lesson I had said this is typically where you would write an equal sign. So the width of the stage, or W, is equal to 31 less than the length. So the length minus 31. Now I have found in the past that students have struggled with these type of equations. So an additional way, a second way that I would suggest, if you're really not sure, try to figure out which one's bigger than the other and write this number, the difference between them, as a total. So the difference between the width and the length, the total, is 31 feet. So which one of these is bigger? Well, if we look, it says the width is less than the length. So the length is bigger than the width. So if you do the length subtract the width, the bigger subtract the smaller, the total would be 31. So this is an alternative way to write this same equation. And they're the exact same equation, they're just written different ways. Now, this is answering part A because it just asks us to create the linear system. So we start by writing our let statement, and then you should have 2 equations. This first one, and then one of these 2 second ones. For part B, what we're going to do is verify this equation. So Sebi has determined that the stage is 55 feet long and 24 feet wide. Use the linear system from part A to verify. Now this is an important part of systems of equations, is being able to verify. Later on, this will be really helpful when you're solving them on your own, where you're not given an answer. So the verification part goes like this. You take each individual equation. So I'll take the first one. And we have a solution. 55 feet long, 24 feet wide. And we're going to substitute these numbers into our equation and verify that both the left side and the right side are going to be equal. So if I substitute 55 in for L and substitute 24 in for W, and I'm going to begin to solve the left side of this equation. So 2 times 55 is 110, and 2 times 24 is 48. Now if I add these numbers on the left side, I'll get 158 is equal to the right side, which is also 158. So this is verified. These solutions work for this equation. So you can't just verify it in one equation, you have to verify it in both. It has to work for both equations. So if I use the second equation, I'm going to use this one here. The length minus the width is equal to 31. So again, what I'm going to do is substitute the length that was given, which is 55, and also the width which was given, which is 24. So 55 subtract 24 is 31. So again, I'm just working on the left side of the equation, and I'm going to verify that it is equal to the right side. So I subtract these and get 31, which is equal to the right side. It is verified. So since this works in both equations, this is the proper solution.